Hey, you know what? It's past midnight. Almost, well, no, it is Monday here. And I figured, you know what? Let's do another physics rapid review, because why not, you know? All right, so here we go. This is a review for the Unit 2 quiz, whatever you want to call it, for the forces. All right, so it says on the moon, gravity is 1/6 that of Earth's gravity. So the moon's gravity is 1/6 that of Earth's gravity. While on the moon, Buzz Aldrin carried on his back a support system that would weigh 1,760 newtons on Earth. What did the backpack weigh on the moon? So what did the backpack weigh on the moon? So what I'm going to do is basically find out the mass, right? So I'm going to use Fg equals mg. These are the new equations that we have the old equations. We also got, alpha, beta, omega right there. Those are still there. But now these new equations we got are F net equals ma, Fg equals mg. And then the friction force is equal to the coefficient of friction multiplied by the normal force. So we got those new equations. So with this one, I'm going to use Fg equals mg. And I'm going to use this to solve for the mass, to find out how much mass this pack weighs for Buzz Aldrin. So it weighs 1760 newtons on Earth. And Earth's gravity is, let's say, 10. So that means the mass of this thing is about 176 kilograms. So if it's 176 kilograms, now this is all on the Earth. What about on the moon? Well, on the moon, it's going to be the same equation, Fg equals mg, but the mass is going to be the same, which is going to answer part B. So the mass is still 180 or 176, basically the same number. So I'm going to write down 176 multiplied by 1/6 the Earth's gravity is actually 1.67 meters per second squared. So Fg should equal about 293. So I'm gonna basically use the answers here. Hopefully they're correct. If I made any mistakes, please sure to let me know, and I'll fix them. Part 2, it says the net force on a 75 Newton wagon. That basically means like the weight. It's like when you talk about, when you talk about sports or something, you say like, oh, 200-pound football player or whatever. So it's a 75 Newton wagon is 32 newtons. So the force is 32 newtons acting on a 75 Newton wagon. And what's the acceleration? All right. So I can draw a quick little free body diagram here. So I'll draw a quick little free body diagram here on the wagon. So we're going to have the normal force acting up like this. So the normal force is going to act up. You're going to have the force of gravity acting down. And then you're going to have this force, I don't know what it is. It's some force F. We'll call it the force F. And that force is the 32 Newton force. So 32 newtons acting right there. So we're going to use F net equals ma to solve this. So F net equals ma. And then I can plug in F net. Well, F net is just going to be 32 newtons in the horizontal direction, right? In the horizontal direction, it's just 32 newtons acting right there. So it's going to equal the mass times the acceleration. They told me we got to find the acceleration. So then I would divide both sides by the mass. It's going to give me 32 divided by m equals a, but I don't know the mass. So in order to get the mass, I'm going to use its weight. Its weight is 75 newtons. So if the weight is 75 newtons and Fg equals mg, then to get the mass, that's going to be Fg over g. So that's going to be then 75 newtons divided by 10. So the mass is 7.5 kilograms. So if the mass is 7.5 kilograms, all right, this is going to be then 32 divided by 7.5 kilograms. Or here, I'll just write it over here. 7.5 kilograms. So the acceleration is going to be 15.6 meters per second squared. And there we go. Awesome. All right. Moving right along. It says a person weighing 820 newtons stands on a scale in an elevator. What's the person's mass? Well, to get the person's mass, again, we're going to use Fg equals mg. So if Fg equals mg, that means Fg over g, baby g, is going to equal m. So Fg is 820 divided by baby g, which is 10. So the person's mass is about 82 kilograms. And that's about 83.7. Looks like they're using 9.8 in their solution, which is fine. That's close enough. So what is the reading on the scale when the elevator rises at a constant velocity? So what is it when it rises at a constant velocity? Well, if it rises at a constant velocity, a free body diagram would be, so it would be the normal force pointing up, which that's going to be the force acting on the scale, right? Because if you're a person standing on a scale, the force that you exert on the scale, that's what the scale measures. But that's basically the same thing as the normal force, because the normal force is the force. So the force of you on scale is the force of scale on you, right? So the force of the scale on you, that's essentially the normal force, and that's what the scale measures, is the normal force. So then in the opposite direction is going to be Fg. And if we have an acceleration of 0, well, if we have an acceleration of 0, let's see, where can we put this? Let's take this, and I'll throw it all over here. So this is number 3, B. So if the acceleration is 0, we get F net equals ma. F net is going to be, well, there was the normal force pointing up, minus Fg going down. And then if the acceleration is 0, this is going to be the mass of the person multiplied by 0. So this is going to mean then the normal force is equal to the gravitational force, or the normal force would equal the weight. I think the weight was 820 newtons, so the normal force would equal 820 newtons, which is the same right there. All right. And then nextly it says, what would the reading of the scale be if it rises with an acceleration of 5.2 meters per second squared? So now it would be the same free body diagram, but now the acceleration now points upwards like that. So if that's the case, that means the normal force has to be bigger than the weight. So this normal force is going to grow. It's going to get bigger like that. So let's see what that looks like on this. So it would be basically the same. So we're going to say 3c. It'd be the same idea. You get, let's do it in a different color so it looks a little different. F net equals ma. F net is still going to be the normal force minus Fg equals the mass. What was the mass? Mass was 82 kilograms. So 82 kilograms multiplied by the acceleration, which was 5.2 meters per second squared. So the normal force in this case is going to equal 82 times 5.2 minus Fg, which is 820, and you're going to get a normal force of, sorry, plus, right? I got to add Fg to both sides. Add Fg to both sides. So it's going to be plus 820. So that'll give you a value of about 1260 newtons. Again, I'm just using the answer here in order to move along, so you're not wasting time with me calculating stuff. All right. Okay, number 5. A force of 124 newtons accelerates a 22.1 kilogram wagon on a sidewalk with a coefficient of friction of 0.19. Make a force diagram. And then what's the frictional force? So let's see. Let's make a force diagram first. So we're going to do this one here. This is number 5. Oh, sorry. This wasn't 3. This was 4. Sorry about that. This was 4. 4B, 4C. All right, so free body diagram. Let's see. We got force of 124 newtons accelerates a 22.1 kilogram wagon along a sidewalk with a coefficient of friction of 0.19. So a force diagram would be like, okay, so you got the normal force pointing up. Should be a normal force. You got Fg going down. You got this way. Is there going to be a frictional force, they're saying. That'll be kinetic friction. And then you got some applied force going this way. All right. And then the first question is, what's the frictional force? How large is the frictional force? So this is the free body diagram. But then part A, they want to know the frictional force. Well, to get the frictional force, it's going to be the coefficient of friction. This is one of the equations that we learned, multiplied by the normal force. 22.1 kilogram. So, but in order to get that, I want to apply F net equals ma in the vertical direction. So I know the coefficient of friction. They gave me the coefficient of friction is 0.19. So I know the coefficient of, let's see, let's write it up. Let's write it up here. Coefficient of kinetic friction is 0.19. So I got to find out the normal force though. So the normal force, I'm going to use F net equals ma in the vertical direction. So this is all in the y direction. This is all in the y direction. F net is going to be the normal force minus Fg is equal to ma, but a is 0 in the vertical direction. The wagon's not going to fall into the ground or fly up into the sky. So that's going to equal 0. So we're going to get the normal force minus, equals Fg. And then again, Fg is equal to mg. So if that's the case, then I know that the normal force is equal to the mass, which is 22.1 kilograms times 10. So the normal force is going to equal 221 newtons. And now I can take that and plug that in there, and that'll give me the force of friction is going to equal, the coefficient of friction was 0.19 multiplied by 221, and that should give me a force of friction of 41.2 newtons. So there we go. There's my friction force. Now for part B, let's do it over here. So find the acceleration of the wagon. Sure. So again, I'm going to do F net equals ma, but this time I'm going to do it in the horizontal direction. Let's do that with maybe a highlighter. In the horizontal direction. So F net in this case, F net, that's going to be F, the force applied, minus the force of friction, equals the mass times the acceleration. So we're trying to find out the acceleration. So to find out the acceleration, we know the applied force, they told us, was 124 newtons. So this is 124 newtons minus the force of friction. Force of friction we found was 41.2 equals the mass, which is 22.1, I believe, kilograms times the acceleration. So I just need to solve for the acceleration, and you should get the acceleration gets 3.75 meters per second squared. There we go, number 5. So Molly, whose mass is 40 kilograms, is walking 3 meters per second on her way to school. She accidentally slides on a patch of ice whose coefficient of friction is 0.06. What force of friction will eventually bring Molly to a stop? How far will she slide? Make a force diagram. Let's do it. So, yeah, Molly, whose mass is this. Okay, here we go. So this is number, what number is this? 6. So we're going to make a force diagram of Molly sliding. So, well, let's see, there's going to be a normal, this is just like Spider-Man sliding. We're going to get force of gravity pointing down, and then we're going to get a force of friction just like that. All right. What else do we know? So she's walking, 40 kilograms is her mass, 3 meters per second is how fast she's going. Coefficient of friction is 0.06. What friction force will eventually bring Molly to a stop? How far will she slide? All right. So, all right, let's do this. So a similar idea is that to find out this frictional force, so I'm going to do F net equals ma. And I'll do this in the horizontal direction. So doing it in the horizontal direction, F net is the normal force minus Fg equals the acceleration is 0. So 0 times the mass doesn't matter. It's going to be the normal force equals the gravitational force. And again, the gravitational force is mg. So that means then that the normal force is going to equal mg. So the normal force will be her mass, which is 40 kilograms multiplied by g, which is 10. So it's going to be 40 times 10. So a normal force of 400 newtons. So also now using the force of friction is going to be the coefficient of kinetic friction multiplied by the normal force. So the force of friction is going to be the coefficient of friction. So the normal force is 400. Coefficient of friction, I think, was 0.06. I think that's what it was. So we'll get a force of friction. We can double check this to see what the coefficient was. So coefficient of friction was 0.06. So the force of friction then is going to be 23.5 newtons. Boom! There we go. And then what else are we trying to find out? How far did she slide? All right. So here's the thing. Now that we know this, we also then, so I'm going to use again F net equals MA. I'll just bring it more over here. So I'm going to use F net equals MA again, but I'm going to do it now in the horizontal direction. So in the horizontal direction, you just get the force of friction pointing to the left. So it's going to be negative force of friction pointing to the left is equal to the mass times acceleration. So this time she is accelerating in the horizontal direction. So there is going to be an acceleration here. So we got the negative force of friction divided by the mass is going to equal how she accelerates. So negative force of friction, well, that's going to be 23.5 divided by her mass, which is 40 kilograms. So we're going to get an acceleration. This time I do need to calculate. 23.5 divided by 40. 0.59. So I'm getting negative 0.59 meters per second squared. And as you might guess, we got to use then a VOVAT to figure out what the distance she traveled is. Because again, she's going to start here, she's going to end here. So at first she's moving with initial velocity of 3 meters per second. Her final velocity is going to be 0, and the question is basically asking is, how much is she being displaced? Because her acceleration is going this way. So we can do a VOVAT. We know her final velocity is 0. Her initial velocity is 3 meters per second. Her acceleration is negative 0.59 meters per second squared. And we got to find out her distance traveled. I would say use this one. I call it alpha. Let's see, we plug in 0 squared equals 3 squared plus 2 times the acceleration is negative 0.59 times the displacement. And you'll get a displacement of, or you should get, 7.65 meters. So 7.65 meters. Boom! There you go. All right. Let's keep it going. What do we got next? Number 7. It says, you can find your own mass in kilograms with which of the following... with the following information. 1 kilogram weighs about 2.2 pounds on Earth. What is your mass in kilograms? Well, your mass in kilograms is 1 kilogram. Okay? All right. I'm starting to not like this question. I don't know what's up with this question. What is your weight in newtons? So, all right. What the heck? Is this just... okay. I don't know really what this is. I think you're supposed to do your own mass and your own weight. Sorry about this. I didn't mean to... Okay. I guess it's just... So this is just using... If you had a mass of 1 kilogram, then you'd weigh 2.2 pounds. So if you had a mass of 1 kilogram, your weight would be... So Fg equals mg. So that'd be 1 kilogram multiplied by 10. So you'd have a 10 newtons in weight. That's a silly question. I'm sorry about that. Okay, so it says Gunter, the weightlifter, can lift 230 kilogram barbell overhead on Earth. The acceleration due to gravity on the Sun is 274 meters per second squared. Would the barbells be heavier on the Sun or the Earth? Definitely the Sun, because this is much bigger than, so again, Fg equals mg. The mass is going to be the same. That's not going to change. So if g is bigger, then the weight is bigger. So it's going to be much heavier on Earth. how much in Newton would the barbell weigh on the sun if it were possible to stand on the sun without melting? So basically, then we're just going to use this 200. So Fg equals, we're going to use Fg equals mg. We're going to use this whole relationship here. It's going to be 230 multiplied by g, which is 274. And we're going to get this big number right here. All right. So it says, Claudia stubs her toe on the coffee table with the force of 100 newtons. Ouch. For people who were with me in period, I think it was period 4, right? I stubbed my toe on the couch. That was smarts. All right. So what's the acceleration of the table of at a mass of 20 kilograms? Well, I can do this really quickly. F net equals ma. So if it had a mass of 120 kilograms, so F net would be 100 newtons. That's how much force was being applied right there. Equals 20 kilograms times the acceleration. 100 divided by 20 is going to give you 5 meters per second squared for the acceleration. What's the acceleration of her foot, which is 1.8 kilograms. So if she stubs her toe, right, on this table, so here's toe, there's toe, toe on table, well, she's gonna she's gonna exert a force of 100 newtons this way, but then the table's gonna also exert a force of 100 newtons in the opposite direction. So if that's the case, then she also, then we're gonna have F net equals ma for her toe, and we got 100 newtons of force equals the mass of her toe multiplied by the acceleration. You're gonna get 55 meters per second squared, but in the opposite direction. So that's why we're saying negative. All right. And it doesn't, you could have made the table, you could have made it, the table in the you could have made this negative and this positive. It doesn't really matter. It's just going with a convention. Okay. So next up it says, while chopping down his father's cherry tree, George discovered that if he swung the axe with a speed of 25 meters per second, it would embed 2.3 centimeters into the tree before coming to a stop. So it says, calculate the acceleration of the axe. So to calculate the acceleration of the axe, so number 10, we're going to do number 10 down here. So to calculate the acceleration of the axe, that sounds like a Vovet. So to chop down a cherry tree, we got 25 meters per second. Okay, so let's see. Let's do. We got an axe, right? Here's a tree, and then next we got an axe again, but the axe is going to be embedded in the tree, like that. So it went a distance. So at first, here we go. Here's the axe about to hit the tree, like this, right? So at first the tip of the axe is there, then the tip of the axe is here. So there's the displacement right there, and the axe is going to be coming in at some initial velocity like this, but then when it finally hits at the end, the final velocity is going to be 0. So final velocity is going to be 0, and then the displacement it travels is 2.3 centimeters, so that's 0.023 meters, and then the initial speed is 25 meters per second. So we can find out the acceleration by using our old friend, v squared equals v naught. Wow, we're using this one a lot. Plus 2ad. So find the acceleration. Final velocity is going to be 0. So this is going to be 0. So that means this is to isolate the acceleration. It's going to be negative v naught squared over 2 times the displacement. That's going to give me the acceleration. So negative 25 squared divided by twice the distance, 0.023. There we go. So we're going to get an acceleration of negative 13,600. So negative 13,600 meter per second squared. There we go. Boom. Answer for part A. Part B says, if the axe had a mass of 2.5 kilograms, how much force was the tree exerting on the axe upon impact? So this is all for the axe, so we can use F net equals ma. So right, the acceleration would be pointing this way, because you got an initial velocity going this way and it's slowing down and coming to a stop. So the acceleration must be pointing the opposite direction. So now we're going to use F net equals ma. F net in this case would be just the force applied by the tree. That's going to equal the mass. What's the mass? 2.5 kilograms. So it's 2.5 kilograms multiplied by the acceleration, which we found was negative 13,600. So we're going to get a force from the tree is negative 34,000 newtons. Boom! There we go. And then lastly, so that was the force that the tree was exerting on the axe, but now how much force was the axe exerting on the tree? Well, that sounds like a third law problem. So if the tree was exerting a force on the axe to the left, that means that the force was exerting, the axe is exerting a force on the tree to the right with the same magnitude. Third law. Boom! Next up, while playing for the Yankees, boo! Mr. Dwyer is not a big fan of the Yankees. He's a Mets fan, so there you go. Alex Rodriguez swung a 0.15 kilogram baseball and accelerated it at a rate of 3 times 10 to the 4 meters per second squared. How much force did he exert on the ball? So this sounds like F net equals ma. So F net would be it'd be the mass. So the mass of the ball, 0.15, times the acceleration, which is 3 times 10 to the 4 meter per second squared. That'll give you a net force of 4,500 newtons. All right. So in a district soccer championship finals, Elizabeth kicks a 0.6 kilogram soccer ball with a net force of 80 newtons. How much does she accelerate the soccer ball from rest in this process? So again, F net equals ma. So F net is the mass, which is 0.6, multiplied by the acceleration. Whoop, sorry. We got to find out the acceleration. F net is this case because the net force is 80 newtons. Equal times the acceleration. So 80 divided by 0.6, that'll give you 133 meters per second squared. All right. Next up, in her physics lab, Arga puts a 1 kilogram mass on top of a 2 kilogram block of wood. She has to pull with a force of 7 newtons to start the combination moving and 5.4 newtons to keep the combination moving with a constant speed. Determine the coefficient of static and kinetic friction between the two surfaces. All right. So, let's see. Let's draw a free body diagram here. So we're going to draw a free body diagram. So at first we got, let's see, the force she's applying. The force she's applying. And then here we'll have Fs. This is the force of static friction max because this is the force so she applies the force of 7 newtons to get this thing going. Sorry, let's finish our free body diagram. Boom. This is now to get it going. Get going would be this free body diagram like this. Let's then do that. Okay. So she's exerting a force of 7 newtons. So let's see, F net equals ma. So she's exerting a force of 7 newtons. So the applied force minus the friction force equals, in order to get something moving, it hasn't yet moved. It hasn't really accelerated yet. So we're going to say the acceleration is equal to 0 in this case. So 0 times the mass, which is the total mass. This would be the total mass. This is like that homework question you had. The total mass would be 3 kilograms, right? So this is going to be 3 multiplied by the acceleration, which we said is 0, right? So this is all just going to be 0. In other words, the applied force equals the frictional force. So if the applied force is 7 newtons, then the frictional force, that'd be static friction max. So static friction max force is 7 newtons. And to calculate the coefficient of static friction, it's the static friction force divided by the normal force. So we know the static friction force is 7 newtons. What's the normal force then? It's going to be equal to the weight, right? So we can use this relationship to find out that the, so again, use F net equals ma. I'll do it in this color to hopefully make things apparent. F net equals ma, but this time we're going to do it in the y direction. So it's going to be the normal force minus Fg is equal to the mass times the acceleration in the vertical direction. But again, if she's pulling it across the floor, there's going to be no acceleration in the vertical direction. So it's going to be F net normal force minus Fg equals the mass. The mass is 3 multiplied by 0 again. So it means the normal force is going to equal Fg. And Fg is mg. We know this equation, right? So that's going to plug in there. So that means the normal force is equal to mg. So the normal force is equal to the mass, which is 3 kilograms times 10. So that's 30 newtons. And I can take all that and plug that in there. So this is 30 newtons. And I'll get a coefficient of static friction of 0.238. About. Somewhere around there. All right, we're going to do the same thing for... so it takes 5.4 newtons to keep the thing moving at constant speed. So now we're moving this at constant speed. Really, it's going to be the exact same free body diagram once it's moving. So it's the exact same free body diagram, except this is not Fs max anymore because it's moving at constant speed. Now this is the force of kinetic friction. So again, using Fnet equals ma. Fnet in the horizontal direction now is the applied force minus the force of friction. But if it's moving at constant speed, the acceleration again is 0. So this is going to be Fa equals the force of friction. So if the applied force is, what is it? 5.4 newtons once it's moving, equals the force of kinetic friction. So to calculate the coefficient of kinetic friction, it's the kinetic friction force divided by the normal force. So force of kinetic friction is 5.4 divided by the normal force. What did we get? 30 newtons last time. That's not going to change. So we're going to get a coefficient of kinetic friction of 0.184. Please remember, I'm not doing these. I'm looking at the answers for the calculations, just for time's sake. All right, moving right along. Let's see. You got a 500 Newton elevator held by a cable is accelerating at a rate of 4 meters per second squared. Find the tension in the cable. Let's do it. So this free body diagram would look something like this. You got tension pointing up on the elevator. That's what's holding the elevator up. And you also got mg, or the gravitational force, pointing down. A 500 Newton elevator. And the acceleration is going up. So Fnet equals ma. Fnet in this case is going to be the tension force minus Fg equals the mass times the acceleration. So the tension force then is going to equal the mass times acceleration plus Fg. So the tension force is going to equal the mass, which is, I don't know. I got to find that out. So be it. It's the mass times the acceleration, which is 4, plus the weight, which is 500. So to get the mass, I'm going to use Fg equals mg. So Fg over g equals m. So 500 divided by 10. So the mass is 50 kilograms. I'm going to take that and plug that in there. Which once I do that, I'll get the tension force equals 50 times 4 plus 500. And that'll give me the tension force, which is about 704 newtons. All right, next up is 15. A 750 kilogram car traveling at 32 meters per second skids to a halt on 80 meters. What is the coefficient of kinetic friction between the tires and the road? That sounds trippy. Let's check it out. So what it's basically saying is that if you did a skid mark of like something like this, so first you started here, then you're here, the car, which had an initial velocity like this, and then went at rest like this, so this is 0. So there's its initial velocity. Then it would have a displacement, something like this. So this would be its displacement, and its acceleration would be pointing like this in that direction. Let's see. Okay. So what we're trying to find out the coefficient of kinetic friction here. So to find out the coefficient of kinetic friction is the friction force kinetic friction force divided by the normal force. All right. So in order to get the normal force, I'll draw a free body diagram. So the free body diagram would be you get the normal force pointing up, you get the gravitational force pointing down, and then you have this kinetic friction force. That's what causes this thing to come to a stop. So using F net equals ma, if we go in the vertical direction, we get the normal force minus Fg is equal to, the acceleration in the vertical direction is going to be 0. What's the mass of this thing? 750 kilograms. So we got mass of 750 kilograms, but the acceleration is going to be 0. So all this is going to be 0 anyway, which means that the normal force is equal to Fg. Again, Fg is equal to mg. So Fg is equal to 750 kilograms times 10. So that's 7,500 newtons. That's what Fg is equal to. And that's the normal force then. So the normal force would equal 7,500 newtons. I could take that and plug that. That's going in there. But what about the frictional force? Well, I could use then Newton's second law in the horizontal direction. So in the horizontal direction, using Newton's second law, it's going to be negative frictional force equals the mass times the acceleration. So the negative frictional force, so it's going to be FFK over m equals, oh sorry, I got to find, so it's the mass, which is 750 kilograms, times the acceleration. That's what I got to find out. So that's what I'm going to use my VOVAT for. Can I move this? I can move this a little bit. I'm going to move this a little bit. Yeah, just give me enough room to do a VOVAT. So let's see, we're going to do VOVAT. So my final velocity is 0. My initial velocity is 32 meters per second. And the displacement is 80 meters, yeah. Wow, we use this equation a lot. So to solve to get the acceleration, it's going to be v squared equals v naught squared plus 2ad. So I'm going to skip ahead here, this because this is going to equal 0. This is going to lead us to negative v naught squared over 2d equals a. So to get my acceleration, it's going to be negative 32 squared divided by 2 times 80. So my acceleration is going to be, what is that, 32 squared. I don't mean to make that. 32 squared. 32 squared divided by 80 times 2, 160, 6.4. So I got negative 6.4 meters per second squared. So that's my acceleration. So if I know that, so negative 6.4 meters per second squared. So that basically tells me the magnitude of my frictional force. These things cancel out. The magnitude of my frictional force is going to be, well, I can just look at the answer here. Oh, sorry, that's not the answer yet, because this is just the magnitude of the frictional force. 750 times 6.4. 4,800 newtons. And that is going in here. So in other words, so basically on this I'm going to take this and extrapolate it all down here. So this is going to be mu k equals 480 newtons divided by 7,500 newtons. So it's going to be 48 divided by 75. 0.64. Is that right? Oh God, I hope so. Yeah, about right. That's about right. Yep, that's good. I'm happy with that. Probably because my approximation to 10 for acceleration due to gravity. Let's see. A 50 Newton box slides across the floor with a coefficient of friction of 0.35. what force is needed for the box to accelerate at a rate of 8 meters per second squared. So what forces need for the box to accelerate like that? Okay, so basically 50 Newton box, size across floor, it's got friction. So here it is, here's the box. You're going to have a normal force pointing up. You're going to have the force of gravity pointing down. You're going to have kinetic friction pointing this way. And then you're going to have an applied force, let's say, pointing that way. So if we do F net equals ma, let's see, let's do the vertical direction first. So in the vertical direction, we're going to have the normal force minus Fg is equal to the mass times acceleration. So the normal force minus Fg is equal to, do we know the mass? So it's a 50 Newton box. Okay, so let's go to Fg equals mg to get the mass. So Fg over g equals m. So if it's a 50 Newton box divided by 10, this is a 5 kilogram box. So this is going to be 5 kilograms multiplied by the acceleration in the vertical direction, which is 0. So this basically tells me that the normal force is equal to Fg. So then the normal force is equal to 50 newtons. Okay, what about in the horizontal direction? So we got Fa minus the force of friction is equal to the mass times the acceleration. So Fa, that's what we're trying to find. So let's isolate it. So it's going to be equals ma plus the force of kinetic friction. So Fa equals, we know the mass is 5. The acceleration, I don't think we know. Do we know the acceleration? Yes, they did. They did 8 meters per second squared. So this is 8 plus the force of friction, though we don't know. So if we can find out the force of friction, we got this thing. So this is going to be Fa equals 40 plus, and we get the force of friction, we got this thing. Well, I know that the force of friction, let's make it like this, the force of friction is equal to the coefficient of friction multiplied by the normal force. Do I know the coefficient of friction? Yes, I do, 0.35, yay! So the force of friction is going to be 0.35 times the normal force, which I found over here. So this is 50. So the force of friction is equal to 50 times 0.35. $17.5 newtons. So this is going to be, so the applied force is 57.5 newtons. Is that right? Yeah, about. Once again, I'm approximating to 10 as opposed to 9.8. That typically puts it off a little bit. Final question. A 12,000 kilogram helicopter has an upward thrust of 200,000 newtons from its blades. Find the acceleration of the helicopter. Let's do it. So we got a force going up. So here's the thrust force pointing up. You got the weight pointing down. And this thing's going to accelerate upward like this. That's what they're saying. So we're going to do F net equals ma. F net is going to be the thrust force minus Fg equals ma. What do I know? 12,000 kilogram helicopter and 200,000 newtons from its blades. Okay, so from its blades, that means the thrust force is 200,000 newtons. So again, instead of Fg, I'm going to use Fg equals mg and plug that into there. So this is going to be mg equals the mass times the acceleration. So that's going to be 200,000 minus the mass is 12,000. 12,000 multiplied by 10, which is what g is, equals the mass. The mass I just need to divide by, so divide by the mass, which is 12,000, and I'll get the acceleration. And if you do that, you should get an acceleration of 6.87 meters per second squared. So hopefully that helped. If you're confused by anything, please feel free to stop by during office hours, and I'll see you guys later. Bye!